Okay? Turns out that, as I say, that's a fairly easy one to restrict. But there are some semantics behind the database or behind the information that make certain queries easier to get at. So for instance, I know salaries can't be, well, depending on who you are, but salaries can't be negative. So I know sort of the boundary, and I know, if the manager's, it's a salary, so they're going to make, almost this or something like that. So now I have this bound on that already. And same thing with purchases. I know, when markets are open and, and so on, so I can tell when they can't purchase it, the raw material on this day or so on. So the semantics, with the meaning behind the data, becomes also important. Now, what we're looking at now at the University of Massachusetts is expressing what we call a stopping function. And what our stopping function does is stop disclosing things when you are about to get a sensitive piece of information. And then I'm going to also talk about the problem of restricting collusion. The stopping function has some of these requirements. One is identification, what is known, your histories. So and this is one of the problems with query histories, is what we keep everything that you've ever asked. Now, that's a very intensive memory and processing problem. For some of us, we let other people solve processing problems, and we'll solve other problems. So now we're looking at ways of expressing histories in shorthand form. I guess that's the easiest way to put it. So that now I can go back and look through that history and not have to search through, do a little bit easier search, I guess that. And then we also have to understand the stopping function has to know what we mean by knowing something. And not just have it, but knowing. And then, and how long until you do not know some piece of information. So we have to keep track of when things change to the queries that you've already asked and be able to throw those out. Here's basically what our approach is right now. If you look at that line, we're looking at ways of expressing the knowledge function. And so that star represents a piece of sensitive information. We can now disclose information. We have now disclosed that knowledge function. And so that piece of information is still secure. They do not have that because it's not, if you will, underneath that curve or on the curve. And that's one of the problems, is identifying where that curve is and where that star actually is. Because, that's problem number one. But here's the other problem with the stopping function is what is the confidence interval that I've given you on that piece of information? Right now, that piece of information has been disclosed, and they have it. To the degree that I don't want them to have it, because that confidence interval around it includes that function. So we've already had a breach of sensitive information at this point. Here is another new knowledge function. So I'm about to disclose something to you, and now here's our new function. It now includes that piece of information, even including the confidence interval. So now that's also been disclosed. So I have to stop. The stopping function has to know what that new function will look like to you. And that's an issue that we're arriving at now. It's an interesting problem that, fortunately, doctoral students like to dig at some of these. We have one doctoral student who said, I can't think of anything interesting to do. And I said, then you should not be a doctoral student. If you can't think of anything, if you have to think that this is not a problem, then I have at least some time to play around with. Now, that's all nice. And it turns out that we have, if I simply consider single-person queries, the problem is just intractable. When I start looking at the collusion issue, it becomes really hard. And what we mean by collusion is people obviously can share information. And how do they share it? And how are we going to define when sharing occurs? This also, we have to decide, does everybody have all of the information? And what exactly was shared? And that's a problem that we're addressing right now, and I'm going to show you some of our solutions for that as well, or the way we've started this. And it's interesting, we decided, and this is not an easy decision, but do we decide that it's the smartest person in the network that knows everything? And what I mean by that is we have naive investors. Should I give a knowledge function for every person, or should I assume the maximum ability to make decisions? And we've decided that it's the maximum. The smartest person in the room, if you will, is the one that's going to drive this function that we have. And then we have to, right now we've looked at, can we express and monitor it as a person-to-person network problem? and which we are starting to look at right now, like a social networking. Now here's something that I've looked at, and that's introducing chaos into a network. What's going on right now is for some criminal networks, they are monitoring the network, but they don't want to upset the network, because then they'll just move someplace else. So we don't want to destroy the network communications, because then we just have to find them somewhere else, wherever they've gone. So we want to introduce chaos, but it has to be in some way that they don't know that the chaos has been introduced. And that's what we're looking at right now. Okay? Here's the collusion problem, basically. You know, the red and blue have visited various sites that have accessed information about company, whatever, and now they've communicated with each other. They have networked with each other. Does that constitute what both of them know? Well, we're going to assume that it does, okay? And the way we're approaching it is similar to the way that it's been approached on websites or web searches. We're looking at authoritative sites, establishing authoritative sites for certain pieces of information. And when you visit that site, that authoritative site, you are assumed to have whatever that authority has. And so when you do a search on, you know, whatever, one of the ways that you approach it is by giving you what they call authoritative sites, and there are ways to do that. And so that's what we're looking at right now. Red person has visited 2 authoritative sites. Blue has visited 3, but one of those authoritative sites is now connected to another authoritative site. So now they have that as well. And so together they actually have visited 6 sites together, and now they have that 6 pieces of information. We've heard before that providing more information seems to be a good thing. Yes, everybody would like more. The question is how much more, and what does that mean? And we haven't really approached that. Can we even audit or review this approach to disclosure? How would you audit 100,000 disclosures a minute? And that is a problem, and if they're individual pieces of information. Can we just assume that availability is disclosure, and can we keep that? If management can say, I don't want them to know this, can we keep that secure? And that's what we're working on right now. Now, we're also looking for funding from the DoD, because this last question turns out to be almost the same thing. Do they know enough to make a weapon of mass destruction? Okay? That's the same kind of query. That's the same kind of information. And so we have some people who know nothing about business or accounting or anything like that, but they've become interested in this because the Department of Defense would like to know if people know how to build this weapon of mass destruction, whether they visit enough sites. That's it. Thank you.
Good morning. First, let me introduce myself. I am not a professor. I am a certified public accountant in public practice. I think I'm the oldest one in public practice. I'm 45 years. Did I beat the 2 of you? Yeah? Okay. 45 years. My background, I'll give you a little bit of my background, because what I'm going to show you has nothing to do necessarily with internal control monitoring. It has to do with, as an independent auditor, how we use continuous assurance to do an audit. Okay? My background is I spent most of my years at Touche Ross as a partner in charge of the real estate practice until 1990, when the merger came with Deloitte. And Deloitte informed all of the industry groups that we're going to put everything on hold for 5 years because we got to integrate the merger. So I therefore left, went to California, and started to develop a technology consulting practice using continuous auditing concepts. And we have various approaches in using it, and what I'm going to discuss with you today is basically what the approach is and how it differs and how it conforms to internal control. First of all, it is a completely independent process. This is the flow chart. What I mean by an independent process is you just heard about security. What we generally do is, as an accounting firm, and generally I advise accounting firms in doing this, they go in and they basically have an independent access to the complete database. How it's secured, whether anywhere from non-disclosure agreements to various security methodologies. One of my technology co-founders works on that.